Hello, everyone. Welcome to the Scientific Sense podcast, where we explore emerging ideas from science, policy, economics, and technology. My name is Gill Eapen. We talk with world's leading academics and experts about their recent research or general areas of topical interest. Scientific Sense is an unstructured conversation with no agenda or preparation. We cover a wide variety of domains where new discoveries are made and new technologies are developed on a daily basis. We are most interested in how ideas affect society and help educate the world how to pursue a rewarding and enjoyable life rooted in science, logic, and information. We seek knowledge without boundaries and constraints and provide unedited content of conversations with researchers and leaders who love what they do. A companion blog to this podcast can be found at scientificsense.com, and this podcast is available on over a dozen platforms and directly at scientificsense.net. If you have suggestions for topics, guests, and other ideas, please send them to info@scientificsense.com, and I can be reached at gill@eapen.info. So before we start, I want to mention that I was recently introduced to a company, Magic Mind, who sent me samples of their product that boost energy and focus. The ingredients are natural, including organic matcha green tea, lion's mane mushrooms, cordyceps, choline, ashwagandha, turmeric, and vitamin C and D. The product is well formulated and nicely packaged, a small bottle for a single dose that can be consumed in a few seconds. I found the product very useful to keep me focused, reduce stress, elevate mood, enhance cognition, and generally keep a healthy immune system. I found it particularly useful when I'm tired. There are no controlled clinical trials yet, but the company is working on it so that the consumers can have excellent scientific data. I would recommend you try it and let the company know of your feedback. They love to hear from their customers. The product again is called Magic Mind and is available in most online retail stores. EPEN 20 to get a 20% discount. That is EAPEN 20. You can also go to magicmind.com/Jan Scientific Sense, JAN Scientific Sense. My guest today is Professor Phoebe Koundouri, who's Professor of Economics at the Athens University of Economics and Business and Professor at the Department of Technology, Management and Economics at Technical University of Denmark. Her research and policy interests are in innovative human-centric interdisciplinary systems for the sustainable interaction between nature, society, and the economy. Welcome, Phoebe. Yeah, so thanks for doing this. So I want to start with one of your review papers, Behavioral Economics and Neuroeconomics of Environmental Values. You say here, identifying mechanisms of real-life human decision-making is central to inform effective human-centric public policy. Here we report larger trends and synthesize preliminary lessons from behavioral economic and neuroeconomic investigations focusing on environmental values. We review the currently available evidence at different levels of granularity, from insights into how individuals value natural resources, evidence from work on group externalities, common pool resources, and social norms, to the study of incentives, policies, and their impact. Yeah, I always wondered about this, Phoebe. So I have done some work in pharmaceuticals, energy, and high technology, where we value intangibles, where there's sort of uncertainty and decision flexibility. And I always wondered how individuals look at natural resources. There is obviously a lot of externalities there. They don't derive the benefits directly. And so what do you find here in the review?
Well, what is important to understand is that for many things that things in inverted commas for many variables that are crucial to the human welfare, crucial in supporting human welfare, it is the case that they are not traded in markets. If a good or a service is not traded in markets, then it's difficult to identify its value and its contribution to human welfare. You might be aware of its contribution to human welfare, but it's difficult to identify and quantify the value. If you have a market, of course, the price reveals the value people place for a unit of that good of service. If you don't have a well-functioning market or not a market at all, then this value goes unrecognized, is hidden. And it is important to retrieve this value. And this is the focus of a long series of my papers. It is important to retrieve the value with any method that you can develop that it is reliable and robust.
Yes,
because my work focuses on the interaction of natural systems and socioeconomic systems, it is important to be able to retrieve the value of natural systems, the services and the goods that derive from them. And it is also important to be able to retrieve the values relevant to social systems that might also be hidden. And there is a big section in economics, which we call valuation economics, and try to retrieve these values in order to understand how we can influence behavior towards the direction that will allow us to optimally allocate these resources in a way that it integrates its endowment, that is, in a way that understands that they are not in abundant supply, and their scarcity should be integrated into the optimization systems that we employ in order to allocate the resources across space and time efficiently.
Yeah, so I want to dig into the methodology a little bit, Phoebe. Mm-hmm. So we have similar problems in industry too. We have to value non-publicly traded assets like patents, intellectual property, emerging ideas, technologies, R&D. So we have similar situations, a lot of uncertainty and decision flexibility. And we typically deploy options pricing principles to value private assets. And so I always wondered, how do policymakers value these decisions? Do they have a methodology? What methodologies do they use?
Policymakers or scientists?
Both, right? I mean, if a policymaker is more important because at the end of the day, they're going to make a decision as to which direction to head. And so I'm more interested from a policy perspective. Yeah.
Policymakers, it depends with regards to which policymaker you are referring to. Policymakers are informed and construct policy for issues that are difficult, like this one, by scientists. So first, there is a vivid scientific activity that is ongoing, with regards to what is the optimal way to retrieve willingness to pay, to retrieve the human-centric value of different public goods and externalities. And of course, if you are looking at European policies, which is the most advanced policy framework with regards to the integration of natural systems, then there is a requirement in cost-benefit analysis when the project has a significant impact on natural resources and the environment to use no-market valuation methods in order to retrieve an estimate of the value of the good today into the short, medium, and long-run future, and based on this value, aggregating this value with other market values that the project might produce to be able to reach a conclusion whether the welfare increase that the project or the investment or the policy that you want to introduce will bring a positive change in social welfare. So in Europe, it is quite advanced, and it is in the policy framework explicitly, and it is transposed into national law in most of the European countries. However, because this is a science hectic and data hectic exercise, it is important that the science, policy making, and also the science and different stakeholders that are involved in the project are in conversation. And this is why we say that not just interdisciplinarity, but intradisciplinarity is very important, because these methodologies engage experiments, either field experiments or laboratory experiments. The design of these experiments is extremely technical in terms of the statistical and econometric expertise that are required in order to put together the design, in order to implement the experiment, and in order to analyze the results of the experiment, and based on those results, estimate the value, and based on that value, reach a policy recommendation or an investment decision.
Yeah, so but without a market-based methodology, how do you account for biases? Because if it's just an aggregation of biases into the valuation, then anybody can get pretty much any value. So it has to be market-based somehow, right?
These are about goods and services that are non-market. So the idea behind these methodologies is that you create, let me call it an imaginary market framework in which you engage a representative sample of your potential consumers or users of the service or the good. And in that engagement, you basically simulate an imaginary market where at the end of the day, the subject that is involved in the experiment is able to state a willingness to pay for changes in the goods characteristics or levels of these characteristics. So these experiments, as I said before, these methods are based on the mathematical underpinnings of the microeconomics of market behavior. And they are basically creating an imaginary space where that market is simulated through not reality, but it could be either information, pictures, even in my case, which is state of the art, in my team, virtual reality. So basically, the subjects go through virtual reality experiments, simulating market-like circumstances, and they are being incentivized to act as if they were in a market by understanding the supply and demand conditions, by understanding the scarcity conditions, and then decided how much the good or service are in question is valuable for them, how much they would be willing to pay to consume it, to conserve it, to have the ability to continuously using it.
Yes, since you're simulating though, Phoebe, I was wondering, a simulation takes a set of assumptions. If the assumptions are not market-based assumptions, it's based on scientists' expectations, policymakers' requirements, then it's a simulation that is not quite real, right? I mean, how can we really believe what comes out of that simulation?
I don't understand the question. Why do you think it's not real? If you have, for example, you are trying to understand how much climate change affects the welfare of people, and in particular, how much they would be willing to pay to avoid, for example, one particular extreme weather event that its occurrence increases in terms of frequency and in terms of severity in the next so many years. So you have a very real situation, which is the event that is happening. You have a very real situation in showcasing the effects of this event in a particular sector of the economy, in a particular household, in a particular region of the country. So these experiments are very specific. And then you simulate different changes, the different policies or investments. For example, if you're looking at a flood, you might have, you might be contemplating as a local authority to invest in an early warning system and an executive plan for hedging against the risk of floods. So you know what you are expecting from this investment. You know what you might be able to save if the event happens, if the flood happens. And then you put all these different scenarios to people with different combinations, exactly as it would happen in a real world situation where you would have a time series and a cross-section of past events and their costs and benefits under different scenarios. And at the end of the day, you use the reaction of people to value how much they would be willing to pay. When they are asked how much they are willing to pay, they are reminded of their budget constraints. They are reminded of their characteristics that are variables that influence the willingness to pay. So it's really very precise, and sometimes it's even better than data from the market, because as we know, very few markets are perfectly functioning. So it is quite a challenge to have a correct valuation of changes, of willingness to pay for changes in the quantity or quality or both of goods or services. So
How many
these are.
how many people
Mhm.
are typically involved in these experiments?
It depends on the experiment. So it depends on the population. If you have the effect, you define the project, you define the affected population, and then you need to identify a representative sample of that population. So it's not only the number, it could be from 300 people to 10,000 people. It depends what you are looking at. It is also the composition of the sample, the geographical location, the education level, how many children, the income level, the gender, the race, many different characteristics. So it is the usual way for retrieving a representative sample from a population at hand.
It is still pretty small, right? 300 to 1,000. So when we run a clinical trials in pharmaceuticals, we do that for tens of thousands of subjects or patients, and even then, the data is pretty biased. We find problems much later. So how can we be sure?
It depends what kind of sample. What time of population, it depends. In the pharmaceuticals, your potential demand is the whole of the world, right? It's not
Right.
the same. It's not the same for an investment project that has, for example, a location specification. So a flood defense infrastructure concerns a particular municipality. So it depends what you are looking at. A mitigation, a climate mitigation program and a zero net transition for the whole of Europe is relevant for the population of the whole of Europe and probably beyond Europe, because climate change is a global public good. So in any case, it depends on what are the specifications of the project. You have to define the project and then decide on the population that is relevant and the sample. So usually these are very, very useful results. At the moment, my team, IFORIA, the Alliance of Excellence for Research and Innovation on IFORIA. IFORIA is a Greek word for sustainability, which is the biggest sustainability focused research team in the world. We are now collecting all the primary studies or valuation studies for goods and services that are external to the market. And these are not just environmental and natural resource related, but also health, defense, infrastructure, and so on. We are collecting all the primary studies on a digital platform, AI-based digital platform that endeavors to allow for the ability to have a value for most of the crucial for policymaking decisions, goods and services, at different locations across the globe. It's a huge project. There are thousands of such studies with different methods. There are different methods retrieving them in the spectrum of non-market valuation methods. And these methods have been used as evidence in courts for oil spills, for example. Nothing is 100% accurate. Nothing is without biases, but they are very good approximations for allowing us to have some robustness in deciding on how to allocate resources that are external to markets, and to that effect, how to create a market. For example, it is impossible to create a market for CO2 emissions like we did in Europe without having an initial understanding of the value of these CO2 emissions, that is the negative value of the CO2 emissions, what should be the tax that someone should pay, what would be the cost that someone inflicts on the rest of the society and on the future, its own future and others' futures, if they continue to emit without taking into account the costs that they are imposing to the rest of the society and to the days that will come after their emission. It's not about future generations, it's about the next year. How worse will be the situation with climate change, and how this situation really turns back on those who actually create climate change, but not only those. So it's a time externality, it's so there is a dynamic externality which you have to evaluate, is a static externality which you have to evaluate, and then go and build markets, and also be able to confirm whether the market that you build is functioning well. Is 10 euros per ton of CO2 emitted a good price, or is 400 euros the relevant price? So for all things that are important in our lives, mostly natural capital and part of human capital as well, we need to have some way to identify the value that they bring into our economic systems. And if you think that we have natural capital, human capital, and produce capital, the only capital that we more or less know its value is the produce capital. So there has to be a very intense scientific activity to identify ways to evaluate the other forms of capital.
Yeah, so if I understand this correctly, Phoebe, if you use willing to pay, willingness to pay in a local market, you are basically solving an optimization problem. It's not a valuation problem in the sense that you have no external market. So we don't know what the value of an action might be because there are no markets for it. And so if you survey 300 people and their willingness to pay for something in a local market, it is really sort of an optimization problem, right? Not a valuation problem.
Why a valuation problem is not an optimization problem?
Because evaluation
value derives from the fact that you have a resource which is scarce, but is also needed, and you decide how to allocate this resource based on, let's say, demand, that is based on preferences. The way preferences and budget constraints identify how much I am willing to pay for a good or service, it's an optimization problem. But valuation, as I said in the first sentence of this conversation, it's based on the microeconomic underpinnings of demand and supply. Demand is derived by the intersection of indifference curves and budget constraints. And the supply curve is also an optimization exercise between how much I can produce given the resources that I have, the scarcity of these resources that defines their cost, and my technology. And then after I have derived the demand and supply, I have them functioning together in a market. And this togetherness, let's say, identifies the price, and this price is the revealing of the willingness to pay. So in a market, the willingness to pay per unit of good or service is the price. In a non-market situation, you need to implement this optimization. Again, you need to retrieve the demand and supply curves. Usually retrieving the supply curve is much easier. Retrieving the demand curve, because it has to do with people preferences, it's more of a challenge, but this is where the different valuation exercise exists. And once you retrieve them, then you identify where demand and supply meet, and you identify the price for the good, the willingness to pay. So,
but these are typically options, meaning they have a lot of uncertainty, and there are sort of sequential decision making going on here. So they don't quite fit with the supply demand curve for pricing.
they actually do exactly fit with the supply and the demand curve.
How do you incorporate
The experiments, exactly as you incorporate it in the market. In a market, there is uncertainty about the future. There is uncertainty about the presence with regards to the quality of the good, with regards to the geographical availability of the good, with regards to hidden information, with regards to uncertain information. There is even ambiguity, not just uncertainty, with regards to the probability of events and so on. So ambiguity, meaning that we don't even know the probability of some events, not just uncertainty. So like you have it in a market, in the exact same way, you present the level of uncertainty and ambiguity in an experiment. So whatever the agent, the consumer is faced with in a real market, he will have it in and it's important because you cannot restructure all the details of the market. But whatever is important, and we believe that it captures the main elements on which agents, decision makers are focused on, it is reproduced in the framework that we present the agent in order to retrieve the price. So whatever uncertainty, whatever market imperfections you might get in a real market, you can also simulate in the market, which does not exist, but it has these characteristics. The market does not exist just because the root of the non-existence of the market is basically lies in the fact that it is very difficult to establish explicit property rights, so people can have access or consume the good or service, or destroy the good or service without having to pay for access to the good or service. And because these characteristics of not being able easily to assign explicit property rights, all these resources are either undersupplied or are being, destroyed by the cares of common pool resources. So what you are trying to do is resimulate this particular framework with integrating into the framework the sense of property rights. If you knew that you could influence the quality or the quantity of the good or the service, and somebody would guarantee your property right in a good quality or quantity, how much would it be? Would you be willing to pay for this, given your income constraints and given your other socioeconomic constraints? So it's difficult, it's challenging, but it has to be there, because if it's not there, you are basically admitting that I don't have a way to quantify the value of at least two of the most important parts of capital that I use in production and consumption, natural capital and human capital. And if you cannot quantify something, you cannot improve it. You cannot manage it. You cannot improve it. So that's why I think it's important.
Yeah, so I want to go to another paper that you have, Phoebe, Evaluation of Marine Ecosystems and Sustainable Development Goals. You say here this paper refers to the evaluation of European marine and freshwater ecosystem services. Using a meta-regression approach, we estimate the annual willingness to pay. We talked a little bit about WTP for several classifications of ecosystem services and various biogeographical marine regions across all 27 EU markets. So this is, I don't know if it's in your research, but do you see significant differences between the different EU markets?
Markets of what? Again, significant differences. Significant differences between
in WTP,
what?
In willingness to pay.
Between countries?
Between countries, yeah.
Yes, there are significant differences between countries, and actually the differences are correlated with the performance of different countries with regards to, for example, implementing the SDG on clean water and sanitation. So what you usually find in this kind of studies is that countries that on average the citizens is willing to pay a high value for conserving ecosystem services related to water resources. These are the countries that perform well with regards to the implementation of SDG on water and sanitation. So here you see in a quite explicit way that willingness to pay, which is basically a way to uncover the hidden demand for goods and services connected with water resources at good status, water resources that are able to be used for drinking water, for sanitation and so on, and sanitation services, you find that countries that have a high demand for those, and this means a high willingness to pay for those, are the countries that achieve good performance with regards to the relevant SDG. So basically what this tells you is that for the SDGs that include public goods or externalities, and it is I mean, if you look at the SDGs, there is no single.
What is SDG?
SDG is the Sustainable Development Goal. So we have 17 SDGs. These are goals that are relevant for the economy, the society, and the environment, and the interaction between them in a way that will lead us to sustainability. To a situation where human welfare can be sustained in a human-centric manner, and be able to sustain human welfare means that you also sustain the goods and services and ecosystem services of natural resources, and other public goods. Sometimes these refer to human capital as well. So the SDGs is a framework, a UN Agenda 2030, signed by 196 countries in 2015. It's a very holistic framework on the economy, the society, and the environment that tries to identify where each and every country of the world should be by 2030 in order to support a decent standard of living for everybody, and a probability of continuing that standard of living and advancing and developing into the future. Now, in each and every SDG, for example, you have an SDG on climate change, climate action, SDG 13, on sustainable oceans, marine resources, on sustainable land use, on clean water and sanitation, affordable and clean energy, decent work and growth, innovation, no poverty, no hunger, good health, and so on. Good international relationships, peace, collaboration, and so on. Each and every SDG includes elements that are public goods, that are a positive externalities. So in order to be able to quantify the performance of countries or regions of the world, or subnational areas, or even cities and local authorities, you need to be able to quantify not just market goods and services, but also non-market goods and services. And this huge effort that we are putting in the United Nations Sustainable Development Solutions Network, I lead the Global Climate Hub and the European hub of that network. What we try to do is to identify KPIs for measuring the performance of each and every unit of geographical denomination, starting at global level, European level, let's say national level, regional level, and so on. we try to quantify the performance against different SDG, and in this KPI identification, we always come across of elements that are not measured in any market or are not able to be measured by any physical quantity. They need to be translated into values. And for that, because there are no market for these goods and services, that we need to incorporate into the performance indicator of the SDG, we need to bring in our expertise from market valuation. So it is important to understand, in a nutshell, that human welfare is very much dependent on public goods and externalities, not just static, but also dynamically. And all of this, in order to be optimally managed, the resources that are public, outside markets, or the goods and services and characteristics that are not here to be traded for, but they concern the future, they need to be incorporated in our analysis. They need to be basic elements of our quantification of our performance, and they allow us, once we incorporate the quantification, the evaluation into the KPIs of our performance, then we understand where we stand and where we want to go. If you don't have this kind of evaluation exercise, for example, climate change, you don't really know what is the cost, the benefits of mitigating or adapting to climate change, how much you should invest for it, for how long, where, and so on. So it's a way to translate scientific evidence into human welfare evidence, and based on that human welfare evidence, make your decisions, always acknowledging that there is uncertainty and ambiguity involved, and that people need to make decisions under this uncertainty and ambiguity, because there is no certainty, especially if you're looking into the future.
Yeah, so I guess from a policy perspective, the issue is that these are assumptions that cannot be really quantified in some sense, because there's a lot of uncertainty around it, and there's a lot of technological uncertainty as well, not just status quo uncertainty. So the real policy question is, how do you incorporate all this different pieces of information and not have a lot of biases go into the analysis? It's easier said than done, I guess, right?
As always, and as in any science, even with climate scientists, atmospheric physicists, if you look at the IPCC reports, they are just reports under different scenarios. And even then, you don't have absolute certainty that the scenario that you are considering are actually including the scenario that is going to be realized, right? There is a danger that you are way off. But this is, at least for now, the situation. We face uncertainty, we face ambiguity. We try to make decisions under uncertainty and ambiguity. It's also relevant for market goods and services as well, because you don't have certainty about the pace of technological advancement, for example. You don't have certainty about planetary boundaries. You don't have certainty about things that might bring structural breaks with regards to how long people live. You don't know whether you're going to have difficult events in the future, wars, extreme weather events, earthquakes. So it's so difficult. The focusing exercise is so difficult, but we need to understand how people make decisions under uncertainty. We need to understand behavioral aspects of decision making under uncertainty. And we need to understand whether we can devise instruments, financial instruments, awareness instruments, social structure that allow people to hedge against all these uncertainties and ambiguities in the most efficient way possible.
Excellent. Yeah, this has been great, Phoebe. Thanks so much for spending time with me.
Okay. Thank you so much. What is your specialty? Where do you work? Give me a bit of background. Yes.